Here I'm going to make a factor tree using both numbers and variables. I want to find the greatest common factor between the terms 6x cubed y squared and 3x squared. So the first thing that I'll do when I'm making this tree is I want to break up the term into a number part and a variable part. Just separate the two. So I'll typically put the number on the left and then any letters on the right. All right, next, I want to see if I can break down those numbers. Are they prime or composite? 6 is composite, so it'll break into a 2 and a 3, but that's as far as we can go. The tree would stop there. And I see over here on this side, 3 is prime, so that's as far as I can go with the numbers. I am going to, however, try to break down the variables. I'll separate the x's and y's. And let's see, x cubed means x times x times x. Y squared means y times y. And x squared means x times x. All right, now I've completely broken it down as far as I can go. And I want to identify the greatest common factor. All right, so the first step was just getting those broken down. Now I want to circle anything that they have in common. I see here that we have the number 3 in common in both trees. I also see that we have 2 x's in common. And it looks like that's it. So, in order to find the GCF now, what I need to do is I need to multiply 3 times x times x. There's no reason to do it twice now. You only have to take from one tree because it's something that they have in common. And I'll just simplify it into 3x squared. Now, what's the purpose of finding a GCF? We're trying to find something that would go into those terms evenly. What do I mean by that? I mean that if we were to take the original 6x cubed y squared, we need it to be divisible by the GCF. And we can check to make sure that it is. And then let's see if 3x squared is divisible by itself. Of course it is. All right, so how do you divide one term here by another? Well, we'll divide the numbers. 6 divided by 3 makes 2. And I also see that we have 3 x's on top. And we have 2 x's down below. And we want to cancel 2 of those x's with the 2 below, leaving behind an x and a y and a y, which is xy squared. All right, let's write out this one. 3 times x over 3 times x. Everything's going to cancel here, and we're going to get just 1. So it went in evenly. It went in nicely. There's no denominator needed anymore because everything that was down below is inside the numerators.